Since the beginning of humankind, people have been fighting each other on almost everything, whether it's food, shelter, or difference of opinion. But with the changing world, the battles are also changed. The one battle that is raging in a different technical realm, automotive. It's a fight over electric vehicles and the technology that surrounds them, notably battery technology. If you've ever met a Tesla fan, you'll notice that they're similar to Apple customers, and many of them are. They appreciate Tesla co-founder Elon Musk's dedication and foresight in developing the automobiles. They can see him as some sort of technological leader who has filled their every waking minute with optimism for a brighter future. The thing with Tesla owners is that they are deeply invested in the company. They are the early adopters and, like Apple consumers, will remain Tesla owners for the rest of their life. So what happens if something new emerges that threatens the current quo? What happens if another vehicle manufacturer develops something that is eventually superior? We are approaching a period in history when we will witness this unfolding right before our eyes. Toyota has been in business for decades, far longer than Tesla. Toyota is a well-known and trusted brand, generally referred to as a luxury vehicle manufacturer. They resemble Apple in our perspective, whereas Tesla resembles Android. The title of this video calls to mind the popular 2019 film Ford vs. Ferrari, which portrays the 1966 fight between these two automotive titans. Toyota and Tesla are now fighting for the future of road transportation, and the conflict is becoming better for us viewers now that Tesla has surpassed Toyota as the world's most valuable automaker. Toyota will announce their new solid-state battery technology in 2021, and they have intended to start selling solid-state batteries in their cars in the early 2020s. Current electric car battery technology has a number of flaws that make it unsuitable for long-range vehicles. Advances in battery technology have boosted the range and power of electric vehicles, but none compare to the convenience, affordability, and range of a petrol engine. There is, however, reason to be optimistic. A superior solution is solid-state battery technology. While this new technology may not be suited for all applications, it might lead to increased EV ranges or possibly the establishment of a new vehicle category. For those of you who don't know, a rechargeable battery with a solid-state electrolyte, rather than a liquid or gaseous electrolyte, is referred to as a solid-state battery. This implies that they have a high energy density, can be discharged and charged quickly, and do not contain any combustible materials. Let's first have a look at how solid battery technology works. An anode, which is a negative side of the battery, and a cathode, which is the positive side, are both present in every battery. These two electrodes are composed of a substance that is electrically conducting. Between and within these two electrodes is an electrolyte containing electrically charged particles known as ions. Depending on whether the battery is charging or discharging, the electrolyte enables lithium ions to pass through and join with the anode or cathode. The passage of an electrical charge between the cathode and anode across a circuit is enabled by this chemical process, allowing a battery to create an electric current to power your gadget. When a device such as a light bulb is connected to a battery, a chemical reaction happens between the anode, cathode, and electrolyte, resulting in a flow of electrical energy that powers the light bulb. A liquid electrolyte is used in a lithium-ion battery to regulate current flow, whereas a solid electrolyte is used in a solid-state battery. And it's this distinction that will make all the difference. The following are some advantages of a solid-state battery. Number 4. Smaller and lighter in weight. The quantity of energy contained in a battery is related to its weight, which is measured by its energy density. Solid-state batteries are reported to have a 2.5-fold higher energy density than conventional lithium-ion batteries. Because of the massive improvement in the energy density of solid-state batteries, they will be much smaller and lighter. Batteries with a higher energy density might be significantly lighter while storing the same amount of energy. For mobile power applications, weight is a major consideration. Thus, this might be a game changer. Vehicles such as cars, trucks, RVs, boats, and planes might all benefit from being lighter. Number 3. Charge times are shorter. Solid-state batteries have the ability to function at extremely high rates of power. According to research, they may be able to recharge 4 to 6 times quicker than existing technology while remaining safe. Number 2. A more secure battery. Liquid electrolytes used in lithium-ion batteries are very combustible and reactive. These electrolytes must also be kept away from air. Solid-state batteries don't have any liquid components, thus this volatile component isn't present. While lithium-ion batteries are susceptible to phenomena such as thermal runaway, which can result in an explosion and fire, the solid electrolytes used in solid-state batteries are non-flammable, posing a lesser danger of fire. While the battery will heat up, it contains nothing combustible that will catch fire. In certain cases, these batteries may not even require an external BMS, substantially simplifying their construction. Number 1. Manufacturing is much easier. Working with a volatile liquid that cannot be exposed to air is a significant difficulty that solid-state battery technology may solve altogether. A solid electrolyte might make production considerably faster while using less material and energy. Let's take a look at what we know about Toyota's new technology so far and compare it to Tesla's 4680 battery cells. Many firms have claimed to have made advances in battery technology in recent years, but time has proven that they are not economically viable and never made it to market. Similarly, is Toyota's battery technology merely a gimmick? Actually, this is a joint venture between Toyota and Panasonic called Prime Plant Energy and Solutions, and they are working together to create a new technology through this partnership. Toyota's solid-state batteries, according to press reports, will be able to travel for up to 500 kilometers on a single charge and will only take 10 minutes to charge. Furthermore, this fast charging rate may be achieved with just minor safety issues. Furthermore, Toyota promises that under the same conditions, these batteries will give twice the range of ordinary lithium-ion batteries. Next year, Toyota plans to reveal an electric vehicle prototype using solid-state batteries. They are now experiencing difficulties with the charging cycle, scalability, and production costs. As a result, it is not currently a viable battery technology. Toyota, on the other hand, is projected to begin large-scale manufacturing only in 2030. Tesla, on the other hand, has a pilot line for its 4680 batteries in Fremont, California, capable of producing 10 gigawatt-hours of capacity each year. In terms of future production, Elon Musk has stated that Giga Berlin will be the world's largest battery cell factory, with a capacity of more than 100 gigawatt-hours per year, with the potential to increase to 200 to 250 gigawatt-hours in the future. As a result, by the time Toyota begins mass manufacturing, Tesla will be generating roughly 3 terawatt-hours of batteries each year. Another issue is the expense of producing solid-state batteries. An electric car is already more expensive than a gas-powered vehicle, and adding a solid-state battery makes it unaffordable, notwithstanding Tesla's plans to reduce the price of its batteries by 56% from their current cost of $100 per kilowatt-hours. One of the most significant challenges Toyota has is the solid-state battery's shorter life cycle, which tends to fail after repeated charging. They need to figure out how to make an electrolyte that won't deform when the battery is charged and discharged, causing packing failure. The Japanese government has committed $20 billion to decarbonization technologies and research and development in this sector. Tesla, on the other hand, says that its battery modules would last up to 1,500 cycles, 300,000 to 500,000 miles, with replacement modules costing between $5,000 and $7,000. Conclusion. Finally, Tesla has announced the Tesla 4680 battery, which will charge quicker than their existing battery technology, have a higher energy density, and cost half as much as their predecessor. Furthermore, it can be mass-produced on a large scale to satisfy rising demand. Toyota appears to be less focused on EVs, with just a prototype battery that has yet to clear the obstacles necessary to realize its full potential, with limited manufacturing by 2025, but still expensive to produce. So, while Toyota waits for its great breakthrough, Tesla has a reasonable answer that works right now. How do you feel about this? Tell us in the comment section down below.